Hi, my name's Maxwell Dennison, and today I will be doing my Calculus CCT for page 109, number 12, on the McGraw-Hill-Ryerson Calculus and Vectors 12 textbook. Question 12 reads, a water bottle rolls off a rooftop patio from a height of 80 meters. The distance, s, in meters, the bottle is above the ground after t seconds can be modeled by the function s at t is equal to 80 minus 4.9 t squared, where t is greater than or equal to 0. The part of the problem that identifies the calculus concept is the equation. The distance equation given to us shows us that the problem is from the second unit in calculus, derivatives. This will likely be an application question which asks about the velocity and/or acceleration. In this case, it will be the velocity or acceleration of the bottle. Parts A through D of question 12 read, A. Determine the average velocity of the bottle between 1 second and 3 seconds. B. Determine the velocity of the bottle at 3 seconds. C. When will the bottle hit the ground? And D. Determine the impact velocity of the bottle. Parts A through D will be solved by A. Finding the slope between the points where t is equal to 1 and t is equal to 3. For B, find the derivative of the distance equation and find the value when t is equal to 3. C, determine the positive t value where s at t is equal to 0. And D, using the derivative of the distance equation, sub in the value of t when the bottle hits the ground. Graphs will also be used as supporting evidence to answer all questions. For part A, we need to find the slope between the points where t is equal to 1 and t is equal to 3. To start, we need to find the height of the bottle 1 second and 3 seconds after it rolls off of the roof. To do this, we plug t is equal to 1 and t is equal to 3 into the distance equation given to us by the question. Using bed mass, we find that when t is equal to 1, it is at a height of 75.1 meters, and when t is equal to 3, it is at a height of 35.9 meters. For step 2, we will be using the points found in step 1 to determine the slope between them. To find the slope, we use the slope equation, where the slope is equal to y2 minus y1 over x2 minus x1. Using the points found in step 1, the slope is equal to 35.9 minus 75.1 all over 3 minus 1. This simplifies to the slope equaling to negative 19.6. Therefore, the average velocity of the bottle between 1 second and 3 seconds is 19.6 meters per second downwards or towards the ground. The graph on the left illustrates the graph of the distance equation, 80 minus 4.9 t squared, and has the points labeled at t equal to 1 and t equal to 3, which prove that the point where t is equal to 1 has a height of 75.1, and the point where t is equal to 3 has a height of 35.9. The graph on the right shows us that when a slope of negative 19.6 is illustrated, it passes through both of these points, proving that the average velocity between the points is negative 19.6. For part B, we need to determine the velocity of the bottle where t is equal to 3. To start, we must find the derivative of the distance equation. So first, we start with the distance equation, and using the power rule, we find that the derivative is equal to negative 9.8t. The power rule is the rule that allows us to find the derivative of an equation. This is done by taking all of the x variables in the question, or in our case, the t variables, and multiplying the coefficient of them by the exponent. Then we subtract the exponent by 1, and that gives us the derivative. For the next part, we will be finding the velocity of the bottle at 3 seconds. To do this, we sub in t is equal to 3 into the derivative equation, or the velocity equation. And we find that when t is equal to 3, it equals to negative 29.4. Therefore, the velocity of the bottle 3 seconds after rolling off the rooftop is 29.4 meters per second downwards or towards the ground. This graph illustrates the derivative or velocity equation that we found in Part B. As we can see, the point where t is equal to 3 has a height of negative 29.4, meaning the velocity is negative 29.4 after 3 seconds. For Part C, we need to find the point in time in which the bottle is at a height of 0. To do this, we must sub in 0 for s at t, because s at t represents the height of the bottle. Using the equation 0 is equal to 80 minus 4.9t squared, it simplifies to t equaling to positive and negative 4.04. Next, we must determine which time is correct. To do this, we use the domain given to us for the equation. T must be greater than or equal to 0, which means we know that t equaling to negative 4.04 is not possible because negative time is not possible. Therefore, the answer to the question is t equaling to 4.04, meaning that the time in which the bottle hits the ground is 4.04 seconds after it rolls off the roof. This graph proves our answer because it models the equation 80 minus 4.9t squared, and as we can see, the 0 of the function occurs when t, or the x, is equal to 4.04, meaning that the bottle does hit the ground 4.04 seconds after it rolls off of the roof. For Part D, we need to determine the impact velocity, which is the velocity at the time in which the object hits the ground. In this case, the bottle hits the ground 4.04 seconds after it rolls off of the roof, which we found in Part C. So to find the velocity, we must sub 4.04 in for the t value into our derivative equation, which gives us the velocity. The velocity ends up being negative 39.592. Therefore, the impact velocity of the bottle is 39.592 meters per second downwards or towards the ground. This is proven through the illustration of the derivative equation, which is equal to negative 9.8t. When t is equal to 4.04, it falls perfectly on the line on a height of negative 39.592, meaning the impact velocity is 39.592 meters per second downwards. A career that would use a calculus problem such as this is a financial manager. They direct how a company spends or saves its money. Their responsibilities vary depending on the company size. If it's small, they perform a wide variety of tasks because they oversee all of the company's financial matters. But if it's a large company, they can do a more specialized job, such as managing the accounting, auditing, or financial department alone. Financial managers work for government agencies, nonprofit organizations, private corporations in practically every industry, particularly finance, insurance, business management, and retail. Financial managers earn $50,000 to $200,000 a year on average, and the educational requirements to be a financial manager includes a bachelor's in finance, business, economics, accounting, or a related field. The way they would use a calculus problem such as this is to find what a company must do in order to make maximum profit by determining the maximum of a parabolic function.